Hi, this is Mrs. LaBarbera. Let's talk about this question. This question is using Newton's second law to solve AP problems. This question is from 1996 Mechanics C exam, question number 2. A 300-kilogram box rests on a platform attached to a forklift, as shown. Starting from rest at t equals to 0, the box is lowered with a downward acceleration of 1.5 meters. Determine the upward force exerted by the horizontal platform on the box as it is lowered. To determine the force, we need to draw a force body diagram or free body diagram. So here is the box. So on the box, there are two forces. One is gravity, one is normal force. Gravity and normal force. Since the box has acceleration downward, so gravity should be longer than the normal force. If we have our coordinate as shown, to the right is positive and to the up is positive, we can write down the forces in the y direction. We know N is positive, mg is negative, so sum of the force should be equals to m times ay. That means N minus mg should be equals to may, and N should be equals to m times g plus ay. We know g is 9.8 and ay is negative 1.5. Negative because acceleration is downward. So that's how we get normal force is 2,490 newtons. Continue. At the time t equals 0, the forklift also begins to move forward with an acceleration of 2 meters per second squared while lowering the box. So this forklift or the box is moving in two dimensions, moves forward and also moving down. The box does not slip or tip over. Determine the frictional force on the box. So again, to determine the force, we need to draw a free body diagram. So we know upward force is N, downward force is mg. And because it has horizontal acceleration, it must have a friction. Friction is the one that provided net force to make it accelerate. So again, to the right is positive, to the up is positive. We know the friction in x direction has to be positive. That is F. And this F is the net force which produces acceleration in the horizontal direction. So F should be equals to ma, which gives you 600 newtons. Next question. Given that box does not slip, determine the minimum possible coefficient of friction between the box and a platform. Obviously, this coefficient of friction is static because the box is not moving. So coefficient of friction is friction over normal force. We just solved the normal force from the last question, and we solved the friction for this. For question B, we can simply substitute those two numbers, and we have mu equals to 0.24. Next part, determine an equation for the path of the box that express y as a function of x, not of t. Assuming that at time t equals to 0, the box has a horizontal position x equals to 0 and a vertical position y equals to 2 meters above the ground with 0 velocity. So you have to write a function y as a expression y as a function of x. We don't know that, but we do know x as a function of t and y as a function of t. So let's see. When x as a function of t, this is the quantities we know. We know it starts with 0. We know there was no horizontal speed, has 0 velocity at time equals 0. So excuse me, from there, x equals to 1/2 axt squared. Ax is forward, positive, so that makes 1/2 times 2 meters per second squared times t squared. This gives us x equals to t squared. In the y direction, we know y naught equals to 2 meters because that's what it tells us. We know initial velocity is 0, so from this equation, we can derive y equals to 2 meters plus 1/2 times negative 1.5 meters per second squared. Negative because acceleration is downward. Simplify this, we have y equals to 2 meters minus 0.75 meter per second squared times t squared. But now you'll have to write y as a function of x, so we have to get rid of t. What is t squared? T squared equals to x, and that's how we can write a function y equals to 2 meters minus 0.75 meter per second squared times x. One more question. On the area below, sketch the path taken by the box. So y as a function of x. Let's take a look. From last question, we know y equals to 2 minus 0.75 times x. This gives us a linear equation, a linear relationship. It's a negative linear. The slope should be 0.75. So to graph this, you need to plot a few points. The one point you'll have is when x equals to 0, y should be equal to 2. The other one, when x equals to 2, y should be equals to 0.5. And lastly, when y equals to 0, x should be about 2.67. Yes, it's 2 divided by 0.75. So then you simply draw a line. Okay, this line is a straight line to show that the relationship is linear and the slope is negative. So it's inclined like this and the slope is 0.75. That's it. Thanks.